This question is on numerical method. That means solving an equation. To solve an equation is to find the unknown value of the variable, which is usually x, of that equation. Now, question number A deals with, we have to show that there is an equation fx equals to 0, and that equation has a solution in the interval 0.8 to 0.9. What does that mean? Well, first of all, you have to understand, if you think of an expression or a y equals to fx, a Cartesian equation, it is some sort of a picture. Let me give a simple example. So this is a parabola. So now if you think of y equals to fx, it's a Cartesian equation and it's a picture. But instead, if you think of y equals to 0, that means fx equals to 0, it becomes an equation which needs to be solved. Now this particular equation will have values of x, which is visually the same as where does it cut the x-axis, meaning y equal to 0 at the x-axis. So if you want to solve an equation fx equal to 0, you actually have to see from the picture where does it cut the x-axis. Now if you further explore it, let me show you over here. If you further explore this, you will see that something interesting is happening. If this is the value of x or the root of the equation, then there is an interval. So this thing has a negative value for y and this thing has a positive value of y. That means it will only cut the x-axis if one value is negative and one value is positive, and that's exactly what we are doing over here. So in question number A, what we are doing is to show that fx equal to 0 has a root in the interval 0.8 to 0.9. We find the value of f.8, which is 0.8 squared minus 3 into 0.8 plus 2 cos 0.8 into half. So let's calculate this. Remember to take the calculator in the radian mode because x is in pi. So radian mode. Okay, now we can do this. So this is going to be 0.8 squared minus 3 into 0.8 plus 2 cos 0.8 by 2 is 0.4 and we get 0.08. 0.08 is positive. Next value, let's see f.9. So f.9, again this is going to be 0.9 squared 3 into 0.9 plus 2 cos half into 0.9. So this turns out to be 0.9 squared minus 3 into 0.9 plus 2 cos 0.9 by 2 is 0.45, which is minus 0.089. Minus 0.089. So we have a positive value and a negative value. So it is more or less like this. It is cutting the x-axis. So since the sign changes, we can say the root lies in the interval. Now 0.8 to 9 in the inequality format can also be written with this open bracket and close bracket. It is the same as interval. Question number B, we have to find minimum point, the x coordinate of the minimum point. So for that we need to use the concept of minimum point from C2. So we know at the turning point is dy by dx equal to 0. So let's find dy by dx. So y dy by dx equal to x squared is going to be twice x. Thrice x derivative is 3. Plus 2 is the constant, cos theta is minus sine theta, into chain rule d by dx of half x is half. So it turns out to be twice x minus 3 minus sine half x. This 2 and this 2 cancels off. So at the turning point, meaning at the minimum point, which is P, dy by dx equals to 0. That means 2x minus 3 minus sine half x equals to 0. Now from here we have to directly find the value of x in this format. So it's pretty obvious what we have to do. So we have to write twice x equals to 3 plus sine half x. Therefore x equals to 3 plus sine half x divided by 2. Now, this is also known as the iteration formula. The concept of iteration formula is that we take the equation that we need to solve for finding the unknown values of x and directly find the value of x from the equation, not any formula or anything, just rearranging it and finding the value of x. That's the iteration formula. So question number C is, we have to use this iteration formula. So all we do to the previous one is write n plus 1 and n, and we have a starting value. So we put the starting value into the iteration formula and find better and better approximation. The more values we get, the better it is. So we don't have to do any step. The first thing we have to do is use our calculator to write down the iteration formula. So the iteration formula is, let me start a bracket. So 3 plus sine half x, that means 0.5 x. For x we have to use this alpha button. So x, bracket close, the entire bracket close, by 2 divided by 2. Now this equation has to be loaded into the calculator. So I'm going to press the calc button and I'm going to get the question mark. So what is the input value? So the first input value is x naught equals to 2. That is going to give me the x1, n plus 1, the next value. If I put n equal to 0, I'm going to get x1. Let me put 2 equals to, so 1.92074. X equals to 1.9207. That is good enough. So this is x1. Now we can find x2. For finding x2, let me press calc again. So now what I just found in x1 is stored here in the answer. So for x2, I need x1. That's recursion. You need the previous value. So I'm inputting answer. What is here? 1.9207. That's quicker. So I get 1.9097. 1.9097. Okay, now I have to find x3 also. So we are getting better and better approximation. So again, let's press calc, and the input value here, x2 is stored over here. So this is 1.9081. 1.9081. Now let me restate the answers to 3 decimal places. So x1 is 1.921. x2 is 1.909. For this 7, 9 becomes 10, so it would be 1.910. And x3 is going to be 1.908. So these are the 3 values. Now question number D is, we have to show that the answer that we got, 1.9078, one of the answers, suppose this is the actual answer to 4 decimal places, this is actually accurate. How do you do that? Well, the same thing that we did in part A. We show that the sign changes. That will show that it cuts the x-axis. But how do you know that the interval, what the interval is? So there is a trick to finding the interval for this sum. So the trick is, so you take what value they gave. They gave 1.9078. Then you put a 0 at the end. And you make the interval by adding and subtracting 5. So if you subtract 5, so 80 becomes 75. So 1.90775, and this becomes 1.90785. So this is what happens. So now we can put the value back to fx. Remember, not in the iteration formula, that is for the root. We are checking if there is a root from the original equation. Now what is the original equation? Fx equals to 0. That is this equation, for which we found that the root lies in this interval. But here the original equation that we have is dy by dx equal to 0. Now this is quite tricky. The original equation has to be from which you found the root. So here the function, let me call it gx, is 2x minus 3 minus sine half x. This is what the original equation is, and here is where we have to put the interval, because otherwise it is not going to work. So this is going to be g of 1.90775 and g of 1.90885. 785. So let's put the values over here. So we get this. Remember, it has to be in radian mode. Let me change the standard form. So minus 0.00016 minus 0.0001. What matters is that it is negative. So similarly, let's do this other calculation. 2 times 1.90785 minus 3 minus sine 0.5 times 1.90785. So this is going to be, let me change the standard form, 0.000076. So the sign changes. So since the sign changes, root is 1.9078.